Welcome everyone. I am Dr. R. Praveena, Assistant Professor, Department of Mathematics, PPG College of Arts and Science, Coimbatore. Today we are embarking on a journey into the captivity universe of mathematical induction. Introduction. Mathematical induction is a useful tool for proving that a certain predicate is true for all natural numbers. It cannot be used to discover theorems but only to prove them. Mathematical induction is like a domino effect in proving statements for all positive integers. If you can show that the first domino falls, that is base case, and that if any domino falls, the next one will also fall. This is inductive step. You have proven the entire row will fall. Similarly, induction establishes a statement's truth for all integers by proving it for the smallest, that is base case, and showing that if it holds for any integer, it must hold for the next one, that is inductive step. Next, the principle of mathematical induction. Mathematical induction is built on two fundamental principles. The first one is basis step, that is P of 1 is true. The second is inductive step, that is P of k implies P of k plus 1. There are three induction steps. The first step, known as the basis step, we prove that the statement holds true for a specific starting point n equal to 1, that is P of 1 is true. Step 2 is we have to assume P of k is true for an arbitrary value n equal to k. Next, step 3 is to prove that if true for k, it must also hold for k plus 1. So, we have to prove P of k plus 1 is true. Let's apply the principle of mathematical induction to prove the first example. If n is a positive integer, then 1 plus 2 plus etc. plus n equal to n into n plus 1 divided by 2. Solution. Let P of n be the proportion that 1 plus 2 plus etc. plus n equal to n into n plus 1 divided by 2. Now, with the help of the principle of mathematical induction, let us check the validity of the given statement P of n. Step 1 is the basis step. Let P of n equal to n into n plus 1 divided by 2. We have to substitute n equal to 1. So, P of 1 equal to 1 into 1 plus 1 divided by 2. So, we get P of 1 equal to 2 by 2, that is equal to 1. This is true. Therefore, P of 1 is true. Next, step 2 is inductive step. Now, as the given statement is true for n equal to 1, we shall move forward and try proving this for n equal to k. That is, we have to assume P of k holds for an arbitrary integer k. The statement can be written as 1 plus 2 plus etc. plus k equal to k into k plus 1 divided by 2. Step 3. Let us now try to establish that P of k plus 1 is also true. We will add the next term k plus 1 to both sides of the induction assumption. 1 plus 2 plus etc. plus k plus 1 equal to k into k plus 1 divided by 2 plus k plus 1, that is equal to k into k plus 1 plus 2 into k plus 1 divided by 2 by multiplying all terms by 2. We will get the result as k plus 1 into k plus 2 divided by 2. On taking k plus 1 as a common factor. Therefore, P of k plus 1 is true under the assumption that P of k is true. Example 2. If n is a positive integer, then 1 plus 2 plus 2 square plus etc. plus 2 power n equal to 2 power n plus 1 minus 1. Solution. Let P of n be the proportion that 1 plus 2 plus 2 square plus etc. plus 2 power n equal to 2 power n plus 1 minus 1 for all non-negative integers. We have to show that P of n is true. Step 1. Let P of n equal to 2 power n plus 1 minus 1. That implies we have to substitute n equal to 0. So, P of 0 equal to 2 power 0, that is equal to 2 power 0 plus 1 minus 1. That implies P of 0 equal to anything power 0 is 1. So, 2 power 0 equal to 1, that is equal to 2 power 0 plus 1 is 1. 2 power 1 minus 1. That implies P of 0 equal to 1, that is equal to 2 minus 1. That implies P of 0 equal to 1 equal to 1. LHS and RHS are equal. Therefore, P of 0 is true. Step 2. Assume that P of k is true. It can be written as 1 plus 2 plus 2 square plus etc. plus 2 power k, that is equal to 2 power k plus 1 minus 1. Step 3. Under the above assumption, we have to show that P of k plus 1 is true. That is 1 plus 2 plus 2 square plus etc. plus 2 power k plus 2 power k plus 1, that is equal to 2 power k plus 1 minus 1. Here we are adding 2 power k plus 1. So we get 2 power k plus 1 minus 1 plus 2 power k plus 1. So that 1 plus 2 plus 2 square plus etc. plus 2 power k plus 2 power k plus 1, that is equal to 2 power k plus 1 minus 1 plus 2 power k plus 1. That is equal to 2 power k plus 1 plus 2 power k plus 1 minus 1. We can write 2 power k plus 1 plus 2 power k plus 1 can be 4 power k plus 1. Remaining is minus 1. That is equal to 4 can be written as 2 into 2. So that 2 into 2 power k plus 1 minus 1. By using the formula a power m into a power n equal to a power m plus n. So that we get 2 power 1 into 2 power k plus 1 minus 1. Then P of k plus 1 equal to 2 power k plus 1 plus 1 minus 1. That is equal to 2 power k plus 2 minus 1. Therefore, P of k plus 1 is true under the assumption that P of k is true. This completes the inductive step. Therefore, by mathematical induction, P of n is true for all non-negative integer n. Thank you all.